Hello everyone, in this video we will try to understand Kadene's algorithm. So Kadene's algorithm is used to solve the problem of finding subarray with the maximum sum. So consider this example which is given here below. We have an array which has some negative elements and some positive elements, and we have to find the subarray which contains the sum which is maximum. So a subarray is a sequence of continuous elements. So this can be a subarray, this also can be a subarray, and this also can be a subarray. Now this, that is -1, 1, 5, this will not be a subarray because these are not continuous elements, and this is rather a subsequence. So a subarray is continuous, whereas if you take some random elements from array, that would be a subsequence. So we have to find the subarray, that is a sequence which is continuous, which has the maximum sum. So now in this case, the maximum, the subarray with the maximum sum is this one. So this is the subarray with the maximum sum. So if we try to sum all the elements of the subarray, then 4 minus 1 is 3, minus 2 is 1, plus 1 is 2, and then plus 5 is 7. So the answer for this array is 7, and this is the subarray which has the maximum sum. So we don't have to find the subarray, we just have to find the maximum sum in this subarray, in the array. So we just have to return the sum. So we do this by using two variables. So we'll initialize two variables. The first variable, cur sum, will show the running sum, and then mx sum will show the maximum running sum. So they will both be initialized to 0 initially. Now this will show the running sum. So we will keep adding elements. So we'll traverse the array and we'll keep adding elements to it until it becomes negative. So if it becomes negative, then we will keep it 0. And when it becomes positive again, then again we will keep storing the elements. And we will show the maximum. So cur sum will take multiple values as you go through the array. So we will keep track of the maximum value that cur sum will take, and that will be our answer. So let's do a dry run on our example. Now this is our example here, and we just need to keep track of two variables. First one is cur sum, and the second one is mx sum. So this shows the running sum, and this shows the maximum of the running sum. So first cur sum will be 0, both of them are 0 initially, and now we will go to the first element, -2. So this will be added, -2. Now this becomes negative, cur sum becomes negative, so this will become 0 again, and this will remain 0. This will remain 0 because maximum of 0 and 0 is 0. Now this goes to -3. Now this becomes -3, and now because this is negative, this becomes 0 again, and this will remain 0. Now this goes to 4, so now this becomes 4, and now this also becomes 4 max sum, because the maximum of 0 and 4 is 4, so this becomes 4, and now we add -1, so this becomes 3, and this will remain 4 because the maximum is still 4. Now let's zoom out a bit so that we can expand it. Now this is 3, so this becomes, now we are here at -1. So -1, 4 minus 1 is 3, so this becomes 3. Now we will go to -2. Now we will subtract 2, so this becomes 1. This still remains 4. Now we are at 1, so this becomes 2 now. We will reach 5, this becomes 7. Now 7 is greater than 4, so the maximum sum becomes 4. Now this is -3, so this becomes 4 again. Now this will remain 7 because the maximum of 7 and 4 is 7. So this is our final answer. The final value of maximum will be our final answer. So this is the answer, and this is the maximum sum which any subarray of this array can give us. Now let's look at the code for this problem. Now this is the code. The code isn't very lengthy, and it's a simple concept if you understand the intuition behind it. So both of them are initialized to 0, both the variables, current sum and max, both initialized to 0 initially. Now we will traverse the array, and we will add the array element to our current sum, which is our running sum. Now if it is less than 0, we'll assign it to 0, and we'll keep track of the maximum current sum so far. And now at the end, when we have the maximum sum, we'll return it. So this was the code for this, and now let's try to run it. Now let's use the same example which we saw before. So in our example, we have 8 elements. So the number of elements are 8. Now let's enter the elements. The elements are -2, -3, 4, -1, -2, 1. So -2, -3, 4, then -1, -2, 1, and then 5 and -3. 5 and -3. So these are the elements, 8 elements in total, and the subarray sum, the maximum subarray sum was 7. So the maximum subarray sum is 7, and this is the output, which is as expected. Now this was the code, and this was the concept for this problem. I hope you understood it. Thank you and have a nice day. So we'll see you next time.